This is Numbers with Nicole, and we're continuing with our circle unit, and our lesson is on area of a sector of a circle. So our goal for this lesson is we're going to be able to find the area for a sector of a circle. It could be a shaded area, a region, just a part of the circle, not the whole thing. We're going to end up finding the whole area, but here we're just looking for a piece of it. So to introduce this topic, I want you to pause the video and see if you can shade the given portions of each of the circles. So do that on your own and then come back. If you don't have this picture, draw your own circle and see if you can shade half of it, a quarter of it, etc. All right, so we're going to shade half the circle. Okay, so I'm going to just draw a line, a diameter to cut that circle in half. And here would be the bottom part. All right, well, how much degrees is that? Well, it's half a circle, so that's 180 degrees. How could I calculate that? If I think about it, 360 degrees for a full circle. I want half of that. That is 180 degrees. Okay, so I'm going to shade the other ones in. All right, a quarter of a circle. Well, a quarter is half of a half. So I'm going to make a little L shape to cut that other half that I just made in half. Okay. Well, if half of a circle is 180 degrees, half of 180, which would be a quarter of a circle, well, that's going to make 90 degrees. So I just shaded 90 degrees of the area of that circle. How about a third? Okay, I'm going to estimate the best I can on this third here. So that's like a peace sign, sort of. Right, best I can do. I'm going to shade this part. Okay. You could shade any of the thirds. All right, so how many degrees did I just shade? Okay, well, a third of a circle would be 120 degrees. So 120 degrees is the measure of the central angle for a shaded area that's a third of the circle. Well, now what if I want 45 degrees? Okay, well, this is not a part of the circle, like 1 out of 8. We could translate it into that. But let's think about it. All right, a quarter of a circle rather was 90 degrees. Well, 45 degrees is half of 90. Okay, so I'm going to kind of sketch. I'm going to dash this little line here for my 45. There's a quarter, and I know that 45 degrees is half of 90. So I'm going to estimate half of that 90, and then that's the part I'm going to shade. Okay, so 45 degrees, right? Okay, now what if I wanted to shade a section of the circle that had a radius of 10, that was 107 degrees of the circle? So no longer 45 degrees, no longer 180 degrees, I want 107 degrees. So that's what we're going to figure out how to do. So there's two ways that you can do this. I recommend using the proportion method. That way, if you later when you have to solve for the radius or the central angle, the process is the same. You're solving a proportion, which all of us know how to do. So what we're doing in this proportion is we're setting up part of the circle over the whole or total circle. Right? 360 degrees in the total circle, and in the bottom I would have the area of the whole circle. And then up the top, the central angle is just a smaller angle in the circle, and the area of the sector is just part of the area in the circle. All right, let's go into an example here. Again, we're going to use this proportion that's above, and we're going to compare the part to the total. All right, and this is always the same setup no matter whether you're going forward or backwards. All right, let's do it. So we want to find the area of the shaded sector. So we're looking for the part. It has a central angle of 107 degrees. I'm estimating here. Here's my central angle, 107. It has a radius of 10. We know all radii in the circle are equal. And we're looking for this area, right? So I'm going to call that A sub S for area shaded. And here it says to leave my answer in terms of pi. Okay. We could round it also. It's not a big deal. Maybe we'll just round in this one. Let's see. Okay, so I know my central angle is 107 out of a total of 360 degrees. So my part of the circle to the whole or total circle. Okay, so I need the area for the whole circle. Whole circle. Its area would be pi r squared, and our radius is 10. So that means that is 100 pi for the area. I'm going to leave it in the exact form right now. We'll take care of the rest when we actually solve. So AS, area shaded, is what we're looking for. So that goes here, part of the area over the total area. So now we know how to solve a proportion. We can cross multiply. And since I'm looking for a sub s, the opposite would be multiplying both sides by 100 pi. So I don't need to also multiply by 360 to just then divide by 360 again. Okay, and let's see what we get. 107 times 100. This question said to leave in terms of pi, so I'm not going to push the pi button. And I'm going to divide that by 360. Yucky. Okay, 29.72 repeating. Now remember, I didn't push the pi button in my calculation, so I'm going to write it as part of my answer. It's like leaving an exact area. If I wanted the estimated area, I would then multiply by pi, and then I would round to whatever it told me to. So all that it means by leave your answer in terms of pi is that you're just going to tack the pi on. If they asked you to find an area that is rounded, then we would just multiply pi and round that answer. So the rounded answer, let's say to the tenths place, would be 93.4, where my exact answer in terms of pi is 29.7. To repeating with the bar over it pi, I could change that decimal into a fraction. It makes it really, really large. So we're not going to do that.